And this is chapter 14. And this is section B. Now we're talking about limits, but limits at infinity. Now, if I taught you last year and we studied exponential functions, you would see that we actually have talked about this already. Limits at infinity. So if we look at asymptotes, for instance, they follow rules of limits of infinity. So we've got this function, f of x equals 2x plus 3 divided by x subtract 4. Okay, so you could punch this in your TI Nspire, see what it looks like. All right, let's do that. Okay, so I've got some graphing software here, Desmos Graphing Calculator, and I've punched in this function, y equals 2x plus 3 all over x minus 4, and you can see what it looks like. It's a reciprocal function. We're going to be looking at as x approaches 4, because that's where the asymptote is. At x approaches 4, at x equals 4. Okay, there's an asymptote right here. So look what's going to happen. There's your asymptote. Okay, x equals 4, asymptote, and this is a vertical asymptote. Okay, so as x approaches 4 from the negative side, so as x approaches 4 from the negative side, y approaches negative infinity. As x approaches 4 from the positive side, y approaches positive infinity. So this is how we show that notation. So we've got our function, y equals 2x plus 3 all over x minus 4. As x approaches 4 from the negative side, f of x, I guess we really should call this f of x to use proper notation, f of x approaches negative infinity. As x approaches 4 from the positive direction, f of x approaches infinity. All right, we could also look at as x approaches the negative infinity. What's happening? So as x approaches negative infinity, f of x approaches 2. And it's coming up to 2 from the negative side. As x approaches positive infinity, okay, so this direction, as it approaches positive infinity, then f of x approaches 2 again, but from the positive direction. So therefore we know we have another asymptote, a horizontal asymptote of y equals 2.